Welcome to our lesson on retrieval practice. First, can you open your exercise books and put the title Retrieval Practice in and underline it nice and neatly. You will then be given a worksheet with this retrieval practice task on. Give yourself 4 or 5 minutes to answer the questions. Pause the video until you've completed the task. Here are the answers. Back in Year 7, we looked at the 5 energy stores and they were elastic, gravitational, chemical, kinetic and thermal. Energy is measured in joules. Don't forget a capital J because it's somebody's name. We use a thermometer to measure temperature in the laboratory. And the 3 fossil fuels are coal, oil and gas. The big question that we want to answer in our lesson today is what is the difference between heat and temperature? Once you've stuck your retrieval practice task into your exercise books, underneath it, please write this as the title for today's lesson. Pause the video while you do this. So the aims of our lesson today are to know that heat and temperature are not the same, to explain the difference between heat and temperature, and to be able to give some examples that illustrate the difference between heat and temperature. The first 2 questions I'd like you to think about today are what is temperature and how is it measured? I'd like you to pause the video for 2 minutes and discuss the answer with your neighbour. The definition of temperature is how hot something is. So a sparkler or a candle will be hotter than cold water in a beaker. We know that we measure temperature using a thermometer, but the scale we use has changed over the years. So the most old-fashioned one is the Fahrenheit scale. Now your parents or certainly your grandparents might be familiar with this, but we don't really use it anymore today. Fahrenheit invented the first modern thermometer, and he decided to put the melting point of water at 32 Fahrenheit and the boiling point at 212. And we don't really understand why he picked those particular numbers, and they don't really make sense to us today. Celsius decided to put the melting point of water at 0 and the boiling point at 100, and that meant he could then divide the scale into hundreds, which we're very used to doing. We used to call it the centigrade scale because centi means 100, but we now have changed it to Celsius. If we then look at the Kelvin scale, he uses the same idea as Celsius. So 1 Celsius hotter is the same as 1 Kelvin hotter, but he starts his scale at what we call absolute zero. And absolute zero is the temperature that particles would stop moving at. So the coldest possible temperature that can exist anywhere in the universe would be 0 Kelvin, which is the same as about minus 273 Celsius. But really, it's the Celsius scale that we use on a daily basis. So here we can see that the Celsius scale is the one that we tend to use in everyday life. And the reason it's particularly useful is that water exists on our planet as solid, liquid or gas. And so whether we're looking at the solid ice at minus perhaps 3 or 4 Celsius, whether we're looking at liquid water between 0 and 100 Celsius, or steam or water vapour at above 100 Celsius, those numbers are relatively easy for us to use. The Kelvin scale will be a little bit harder to use in everyday life, but it's really useful for understanding temperatures in space and how temperature, pressure and volume are related. So for example, in something like a jet engine. And down on the bottom right, there's just a summary there of some of the other temperature scales that are used for all sorts of things across science. Now, if we're in the school laboratory, the thermometer bottom middle is the one that you are most likely to see. However, you might have seen the one on the top left if someone's taken your temperature at home, or the top middle if you've had your temperature taken at the doctor's or in hospital. The bottom right are the temperature strips that we quite often use with children to see if they've got a temperature if they're ill. And the other two you might find, for example, in a factory setting. So are heat and temperature the same? Well, I hope that you've realised they're not, even if it's just from the big question at the start of the lesson. But let's have a look and see how they are different. So as we've seen, temperature is how hot something is, and we measure it in Celsius, Kelvin, and so on. On the other hand, heat is a type of energy measured in joules. We met heat or thermal energy back in year 7. Could you now write these two definitions into your exercise books? If you have a different coloured pen or highlighter, please highlight the words in red as these are our key terms. Pause the video for a couple of minutes to give yourself time to do this. Now you have the definitions for heat and temperature. Let's see if you really understand the difference. We're going to have a look at a couple of questions. First, which has the highest temperature? A swimming pool heated to 20 Celsius or a cup of tea at 90 Celsius? Pause the video for a moment and discuss the answer with your neighbour. Hopefully you said the tea is hotter because the temperature of 90 is greater than the temperature of 20. For the next question, I want you to think, which has the most heat energy? Is it the swimming pool at 20 Celsius or the cup of tea at 90 Celsius? Again, pause the video for a minute or two and discuss the answer with your neighbour. Hopefully you said the swimming pool, although this question confuses some people. Although the pool is cooler, you need a lot more energy to heat a large amount of water in a swimming pool to 20 Celsius, whereas you only need a very small amount of energy to heat the small amount of water in the cup of tea up to 90 Celsius. So the pool has more heat energy even though it's cooler. Thinking about the swimming pool and cup of tea question then, we want to think about what affects how much heat energy an object has. We already know that the swimming pool had more heat energy than the cup of tea. There are three things here. First is the temperature. Hotter things have more heat energy, so a hot cup of tea has more heat energy than a cold cup of tea. However, mass is also important. If two objects are at the same temperature, the one with the greater mass will have more heat energy. So if I've got a swimming pool and a cup of tea and they're both at 20 Celsius, then the swimming pool still has more energy because there's more water. And then lastly, the material. Some materials just need more energy to heat them up than others. So to summarise what we've learned today, temperature is how hot something is, and heat is a type of energy. All matter has energy. The faster the particles are moving, the more energy it has. How much heat energy an object has depends upon its temperature, its mass, and the material it is made of. I'd like you now to put the last two bullet points into your exercise books. Pause the video to give yourselves time to do this. Let's find out if you've understood the main points of today's lesson. Have a look at this picture. What is wrong with this? I'm just measuring the heat of this volcanic spring. Pause the video for a moment or two and discuss the answer with your neighbour. Okay, so the problem here is this word heat, isn't it? We've clearly got something which is measuring the volcanic spring, but this is going to be measuring temperature. So we need to replace the word heat with temperature. What's wrong with this? These ice cubes don't have any heat. Pause the video and discuss the answer with your neighbour. Okay, the ice cubes do have heat, they do have some energy. Although they are cold, which means that their temperature is low, they must still have some energy. The particles in the ice cubes are still moving, and therefore there's energy that those particles have. So this is making sure that we understand the difference between temperature, which in this case is cold, and energy, which is about the movement of the particles inside the ice. So these ice cubes do have heat energy. And finally, what's wrong with this? Space doesn't have a temperature. Again, pause the video and discuss the answer with your neighbour. This is a little bit like the ice cube question. Space is extremely cold. It's usually at about -270 Celsius if you're right out in deep space. However, it does have a temperature, it's just extremely low. So again, just because something is very cold doesn't mean it doesn't have a temperature. It's just a very, very low one. So to finish the lesson then, we started with a big question, which was to find out the difference between heat and temperature. Hopefully by the end of this video, you realise that heat is a type of energy, we measure it in joules, and temperature is a measure of how hot or cold something is, which we measure in Celsius using a thermometer.